Hello and welcome to this tutorial on Metaclasses. This is aimed at intermediate and advanced Pythonistas in order to increase your exposure to some of the hooks and magic and customization that you can perform using Python. First, we're going to look at how we can customize instance creation. Classes are constructed using type by default. Code in the body of the class is executed in a new namespace, and the class name is bound locally to the result of the function type. Type takes three arguments: name, bases, and a namespace dictionary. Name is the class name as a string and becomes the dunder name attribute of the class. Don't worry, we'll have a look at these in a second. The bases tuple itemizes the base classes, so anything that the class that we're defining inherits from. The final argument is dict, which is the namespace containing definitions for the class body and is copied to a standard dictionary to become the class.dunderDict attribute. Let's get to some code. Let's define a simple class. When we write this is exactly the same as if we have capital A and we assign to it type, and then the first argument is the string, the capital letter A, it's the name, and then we have the bases tuple, so what this class inherits from, we inherit from object, and then we have the namespace dictionary. We can take a look at these dunder attributes, and the most striking is the namespace dictionary, and it contains everything we would expect it to contain. If we define the class in the usual way, the first way we defined it, we would get exactly the same printed out to the terminal. The easiest way to see how metaclasses allow us to customize the class creation process is to take a look at some code. The trigger for instantiation is calling the planet class here. Metaclasses allow us to customize the dunder call method, which opens up endless possibilities. We're going to create a metaclass here, the first one of our examples, and what we're looking for is that each time an instance of the planet class is created, we're going to print to screen instance of planet created. How do we do this? We define a class as we normally would, but we inherit from type. So now we can write our dunder call method. The first argument is self, as you would expect, and then whatever arguments, positional arguments, and keyword only arguments. In this method, we write instance of planet created. Now when we rewrite our planet class, inside the brackets we can write metaclass and assign to it print on creation. We'll leave the body of the class as it was. And sure enough, when we instantiate Earth, we can see that we have printed instance of planet created. Now let's move on to some more involved examples. We can even put a stop to instance creation. In the same dunder call method, instead of printing, we're going to raise a type error. This time, when we instantiate planet, we have a type error, instantiation blocked. There are endless hooks in Python which can be manipulated, they can be customized, and they can fit whatever your needs may be. The only limit is your imagination. How would we go about implementing the singleton pattern? That's to say, we want to make sure that there's only ever a single instance of our class created. We inherit from type as we normally would to write a metaclass definition, and in our dunder init method, we assign none to self.dunder instance. We then call super. In our dunder call method, if self.dunder instance is none, then we're going to call super and we're going to instantiate the object and return it. However, if there's already an instance there, dunder instance is not none, so we go to the else and we return the self.dunder instance. We attempt to instantiate two objects, Earth and same or different Earth. And when we print their repr, we can see that they're at the same memory address, and when we print whether Earth is the same object as same or different Earth, we see true. So there's only one instance there. Probably the most well-known example of metaclasses, and the one that you're most likely to use, is enforcing coding conventions in classes. Let's say you've developed a library for internal use within the company. You work in a large company. You don't really have contact with the people, your end users, who are going to use your library in the company, and they have no practical way of getting hold of you. Even if they were to communicate with you, the class hierarchy is so huge that really, for your sanity and the sanity of the people using your library code, it's worth enforcing a few conventions in your classes, making sure that errors are spotted as soon as possible, really. Here we have enforcer metaclass, we inherit from type, and in our dunder_new method we have the class name, bases, and the class dictionary. So this is great because we can have access to the class dictionary, the contents of the class, at the time of definition. We can pick up errors as soon as possible. In this simplified example, we raise an exception if anyone attempts to disobey PEP8 by only allowing methods with all lowercase letters. Going back to our dunder_new method, for name in class dict, if name.lower, so whatever string name is, we convert it all to lower letters. If it's not equal to that name, then we raise a type error. We print a helpful error message that there's an inappropriate attribute name, and then we say what name that is. If the name of the attribute is all lower letters, we won't raise a type error, and we can return the result of having called super. One of the beauties of metaclasses, one thing that makes it so elegant, is that if you have a really large class hierarchy, you only need to assign your customized metaclass to the root class once. All the classes that inherit from the root class, they will be bound by whatever's in the customized metaclass as well. So here we have child A that's inherited from root, and we have one method, city_finder, and we have child B that has camel case for that method. And as we can see, we get the inappropriate attribute name type error. I hope you've enjoyed this whistle-stop tour of metaclasses. If there's interest, we can go deeper into metaclasses and really have a look at the underlying mechanics. If you've enjoyed this content, please like and subscribe and spread the word. Thank you.